edge computing in the IoT. What is the meaning of edge computing? Any idea? Have you heard about it before? When we talk about edge computing, it's a like distributed computing framework. Okay, it's a distributed computing framework that brings enterprise applications closer to the data source, such as the IoT devices or local edge servers. Okay, so simply when we talk about edge computing, it is a distributed computing paradigm that brings computational power, you can say computation and data storage closer to the location where it is needed, because it's not every time necessary that the computation power, that is the processors, you can say that like power, the computation is with the help of processor, and the storage is simply different thing. It is the data servers, the storage servers are different, and the CPU processors are different thing. So computation is provided by the CPU, but where the data storage is simply the servers which are storing your data, and they are not every time on the same location. So the paradigm that brings the computation and the data storage closer to the location where it is needed, that is simply known as the concept of edge computing. And in the IoT devices, the sensors, like there are IoT devices and sensors which are used for the purpose. Instead of sending all the data to the centralized cloud server, edge computing processes data locally on the edge of the network. And the goal is to reduce the latency, enhance the real-time processing capabilities, and decrease the bandwidth required for transmitting the data to the cloud. So latency will be reduced and the processing capabilities will be higher. Then when we talk about the benefits of the edge computing for the data processing, so reduced latency is very necessary to be taken care of. And when we talk about the reduced latency by processing data locally, edge computing minimizes the time taken, like you can say the time it takes for the data to travel from the source to the cloud. Because every time what is happening, the data is traveling from one place to another. Sometime for the processing power, sometime for the availability of the resources. So the processing, like for the processing of the data locally, edge computing minimizes the time it takes for the data to travel from one source to another, from the source to the cloud and the back, simply and back. So this reduction is latency, and it is crucial for the real-time applications like autonomous vehicles and industrial automations and smart healthcare devices, healthcare systems. And the impact of this reduced latency could be that the faster response times, which enables more immediate decision making and actions, improving the performance of the time-sensitive IoT applications. Then simply when we talk about the bandwidth optimization, so by processing data locally, edge computing minimizes the time it takes for the data. So this will be also like simply decreasing or optimizing the bandwidth, you can say. It's not decreasing, it's optimizing the bandwidth. So bandwidth usage is decreased and bandwidth is optimized, lowering the cost and reducing the burden on the network infrastructure, which is particularly beneficial in the environment with limited or expensive connectivities. So where the limited connectivity is there or expensive connectivity is there, the equipments are expensive, that time we need the bandwidth to be optimized. Otherwise, there will be the waste of bandwidth, there will be the wastage of resources. So you have to take care of this thing that the resources are not getting wasted. Then the benefits of edge computing for data processing at the source. So enhanced security and privacy is required. So the processing of data at the edge allows sensitive information to be kept closer to its source, reducing the risk exposure during transmission to the cloud. Edge devices can also implement the security measures like encryption. So the edge computing actually here the encryption and the access controls are maintained locally also for the privacy and the security of the data. And this impact, simply, it improves the security and privacy of the IoT systems, making them less vulnerable to cyber attacks and data breaches. Then the improved reliability. So simply, the edge computing enable local processing even when the connection to the cloud is disrupted or slow. So reliability is when the things are available when you need it. Then only you can rely on anything. When you are not able to, like, reliability means that when you need, then it is available. Okay. And simply, you can say that the local processing is there, with the help of which the cloud is, if the cloud is disrupted or it is simply slow, then also the data will be present. So IoT devices can continue to function and make decisions independently of the cloud. So the impact is that this increases the reliability and the robustness of the IoT systems, ensuring continuous operations in the environment with intermittent or unreliable internet connectivity. When the connectivity of the internet is not there, then also these systems will be working, and this is just possible because of the edge computing for the data processing at the time of source connectivity. Then simply the scalability. So by distributing the processing task across multiple edge devices, edge computing reduces the load on centralized computer server. So simply everything cannot be like loaded on the centralized systems.